Front end of the nuclear fuel cycle. The nuclear fuel cycle is the set of processes to condition fertile and fissile materials to produce energy in a nuclear reactor and subsequently reprocess and recycle, or store them, safely safeguarding the resulting radioactive waste. The fuel cycle begins with the extraction of uranium ore, going through its milling, concentration, conversion, enrichment, fuel irradiation in the reactor, and the steps associated with the selected spent fuel disposal strategy. The nuclear fuel cycle can be divided into two categories, the open cycle and the closed cycle, the main difference being that the irradiated fuel is not reprocessed in the open cycle. In the open cycle, the fuel, once it leaves the nuclear reactor, is temporarily stored, either in spent fuel pools and/or in containers or in concrete vaults, these last two known as dry storage methods. Subsequently, the spent fuel is properly conditioned and definitively disposed of in a permanent repository, such as a deep geological storage. In the case of the closed cycle, the fuel is recycled, recovering part of the uranium still available in the fuel, as well as the plutonium that was produced in the reactor. As can be seen in the figure, the spent fuel, after temporary storage, goes through a reprocessing process to separate the uranium and plutonium, and reuse them to produce new fuels. In the case of the advanced closed cycle, still in the research stage, what is intended is, in addition to recovering uranium and plutonium, to be able to separate isotopes heavier than uranium as transuranium and mainly minor actinides, and some fission products and transmute them into less radiotoxic radioactive isotopes. Therefore, in the case of the closed cycle, the volume and the radiotoxicity of high-level waste, that goes to the final repository, is less than that of the open cycle. All the stages that are carried out before the irradiation or utilization of the fuel in a nuclear reactor, that is, mining and milling, conversion, enrichment, and fuel fabrication, is known as the front end of the nuclear fuel cycle, which is the subject of this module. The steps that take place after the fuel has produced energy in the reactor are known as the back end of the nuclear fuel cycle, which will be addressed in the next module. Depending on the type of fuel cycle, the activities involved are temporary storage of the used or spent fuel, and direct final disposal in the case of the open cycle, or reprocessing and recycling, and final disposal of high-level waste in the closed fuel cycle. Now, let's take a look to the excellent video of the International Atomic Energy Agency.
The nuclear fuel cycle is an industrial process to produce electricity from uranium in nuclear power reactors. The cycle starts with the mining of uranium and ends with the disposal of spent fuel and other radioactive waste. As the first step of the nuclear fuel cycle, uranium recovery focuses on mining natural uranium ore from the Earth. The mined uranium ore is crushed and chemically treated to separate the uranium, which is called milling. This process leaves us with yellow cake, the powder form of uranium oxide. In general, conversion is a process in which the uranium is converted to a form suitable for enrichment. Natural uranium only contains 0.71% of uranium-235, the isotope that maintains a nuclear reactor's chain reaction. To increase the concentration of uranium-235, the yellow cake must be converted into uranium hexafluoride gas. As most nuclear reactors require fuel with a uranium-235 concentration of 3 to 5%, the proportion of the uranium-235 isotope must be increased. This process is known as enrichment. This is done by introducing the UF6 gas into fast-spinning cylinders known as centrifuges, where heavier isotopes are pushed out to the cylinder walls. Enriched UF6 is converted to uranium dioxide powder and formed into small, solid cylindrical pellets. These are packed in long metal tubes which are grouped in fuel assemblies. Controlled fission, or splitting of U-235 atoms, generates heat. The heat produces steam at extremely high temperatures and pressure. The steam then spins a turbine to generate electricity. Nuclear fuel is typically used in the reactor for 3 to 5 years. After removal, it is stored underwater, which provides both cooling and radiation shielding. Later, it can also be stored dry in shielded buildings or casks. Material in spent fuel can also be recycled to produce more energy. Some countries chemically reprocess spent fuel to separate the usable material from unusable waste. For this, plutonium and natural uranium are mixed to make a new type of fuel and can be reused in existing reactors or in fast neutron reactors. Spent nuclear fuel or high-level waste can be safely disposed of deep underground in stable rock formations. Waste is packed in long-lasting containers and buried deep in the geological formations chosen for their favorable stability and geochemistry. The first such disposable facility is expected to be operational in the near future. The IAEA supports its member states in using nuclear technologies in a safe, secure, and sustainable manner.